Hi everyone, welcome to today's tutorial where we'll learn how to find the primitive roots modulo m. Primitive roots might sound fancy, but they're a key concept in modular arithmetic. So let's dive in and get started. In our previous tutorial, we explored the concept of the multiplicative order of an integer, a modulo m. The definition of primitive root is based on the concept of the multiplicative order. Let's clarify what a primitive root modulo m is. An integer a is called the primitive root modulo m if the order of a modulo m equals the Euler's-Taussent function of m. In this case, the greatest common divisor GCD of a and m must be 1 according to the definition of the multiplicative order. To find all the primitive roots modulo m, we need to determine the order of all integers less than m that are coprime to m. The set of integers less than m that are coprime to m is called the multiplicative group of integers modulo m. Primitive roots modulo m exist within this group. If the order of any integer in this group equals the Euler's-Taussent function of m, that integer is a primitive root of m. Now let's break down the code step by step. In this code, we will use two user-defined functions, Euler-Taussent and findOrder, which we covered in previous tutorials. So make sure you've watched those videos for a better understanding. First, we calculate the Euler's-Taussent function of m using the Euler-Taussent function and store it in the variable 𝜑m. We then create an empty array named primitive roots to store the primitive roots modulo m. We use a for loop to iterate through the integers from 1 to m-1. As mentioned earlier, primitive roots exist within the multiplicative group of integers modulo m. The variable a increments from 1 to m-1. At each iteration, we check whether the GCD of a and m is 1. If it is, we proceed to calculate the order of a modulo m using the findOrder function and store the order in a variable named ord. Next, we use an if statement to check if the order is equal to the Euler's-Taussent function of m. If it is, then a is added to the array primitive roots. This process repeats for each iteration. The isEmpty function determines whether an array is empty. Using an if statement and isEmpty, we check whether the array primitive roots is empty or not. If it isn't empty, we print the primitive roots modulo m. Otherwise, we print that there are no primitive roots modulo m. Now let's run the code. Thanks for watching. If you enjoyed this tutorial, don't forget to like, share, and subscribe for more coding and math content. See you in the next video. This is Tough Nut, signing off. Happy coding.